So my name is Casey Lindberg. I recently moved to HKS on the research team, but that was very recent, and today I'm talking about work done while I was at the University of Arizona Institute on Place, Wellbeing, and Performance, and directed by Esther Sternberg. So the title is Wellbuilt for Wellbeing, Using Sensors and Surveys to Explore the Indoor Environment and Health. And the goal really today, since I don't have much time, is to really give you guys a kind of snapshot that I hope to be accessible to everyone here. In terms of some of the interesting findings and some of the interesting methods that are novel that we've done over the last few years with support from the General Services Administration, who is the federal landlord and provides support including office spaces and other support services for about 1 million people in the US. So it's really nice to see that they have invested some research funding to see how those spaces that they provide affect people's health and well-being. And really their goal is to think about how we can optimize spaces rather than just avoid things that we know are really negative. So you'll see a bunch of different types of sensors coming together today, as well as some traditional methods. You could come at this in a bunch of different ways. There are a lot of things going on in an office space, but one thing that's particularly interesting is the case for increasing physical activity. In the 1970s, the majority of workers were what we like to call blue-collar jobs, and by only the 90s, 30 years ago, 25 years ago, the majority was already sitting down in an office space. There are a lot of differences between those types of realities, and one thing is a real increase in the risk of sedentary behavior for office workers. So that's something that we're particularly interested in, and as you'll see is one of the results that we have that was recently published. Another reason we're interested in physical activity is because it's part of this nice feedback cycle of other very positive outcomes, if you have a positive influence on one, that is. So physical activity has been shown throughout years and years of research to be positively correlated with higher sleep quality and vice versa, and also lower levels of stress throughout the day. So we really want to find a way in through the design of a space or through the way a space is operated to affect one of these things or multiple of these things in a positive way, because that'll have a positive influence on the others. And when you can do that, you really affect your whole day. Your body has all these cycles, right? And if you can affect it in one place, it's going to affect you later on. And also can build up over time in years and decades. So before I jump into the Wellbuilt for Wellbeing study, this was just a quick slide on a study that was published in 2010, also supported by the General Services Administration. This was in Denver. It was at a federal building in Denver, and it served as sort of the catalyst for the current work that you're about to see. In this study, just very briefly, they had people pre and post move from a space that had a whole bunch of things that are not desirable to a space that had a bunch of things get better. And lo and behold, they found some physiological responses that improved once people moved between the two spaces in terms of a stress response that I'll talk about briefly, heart rate variability, as well as cortisol. But they didn't have any idea what in that environment was really driving that. It's a very naturalistic study. Ours is too. Plenty of problems in our study as well, plenty of potential confounds. But they only had snapshots of environmental conditions. They weren't able to track people really over time in terms of their environmental exposure. And they only had a couple different spaces. So what we wanted to do with Wellbuilt for Wellbeing was take a bunch of people, hundreds of people, 230 people across a bunch of different sites, in a bunch of different types of offices, across a bunch of types of work, and track things in a more real-time way in terms of environment and physiological health and psychological response. So just a brief overview of the methodology that we employed in the study. Each worker was observed for 3 days at work doing their normal work activities, and 2 nights. Just going down from the top there, we had mobile indoor environmental quality nodes. So these were developed by a company out of San Francisco called Aclima. They do sensing work, and they developed a wear node for this study for us, which captured things like CO2, temperature, relative humidity, and sound on the person. We also had, we used heart rate variability monitors and activity monitors. They're the same device. Those are on your skin through a belt that you wear, or using electrodes, and those were worn by participants all day and all night. People were also pinged about every hour while they were at work about where they were, what they were doing, how they were feeling, how comfortable they were in the environment, how productive they felt. And then we also had stationary air quality nodes that were set up in spaces where we were recruiting people. And of course, we had some other kind of set of spatial attributes that we were interested in, including office type, which is very interesting to the General Service Administration. Quickly, what we gather from the heart rate variability monitor that people wore while they were at work and at home or away from the office and sleeping was a full ECG, so we were able to extract a bunch of different parameters about heart rate variability from that signal. And very simply, oversimplifying that, heart rate variability is a good thing, especially for this population where they're showing higher levels than you'd want. Yes, you want to get stressed to accomplish a task, but then you want to be able to settle back down from that level. So you don't want your fight or flight kind of always at a higher level than you'd want it to be all day long. So we're able to gather that from the heart activity data, and then also a bunch of different parameters from physical activity in that sensor as well. One of the things that we started to observe across all these different types of offices and all these different areas were that people in open bench seating, so seating where when you're seated, you can see other people around you because the partitions are either non-existent or very low, exhibited more physical activity while they're at the office than those in cubicles and than those in private office in that sort of order. And what we were interested in was, okay, well that's great, but what about in a more complex model where we're able to at least account for things we can account for in this naturalistic study? Does that relationship hold up? And it does, and this is just a really simplified sort of abstract conceptualization of what we found, but controlling for a bunch of different things like job type and demographics and whether a manager or not, their self-rated stress both globally and in real time. We found that office workstation type was related to physical activity at the office directly. So those that were in an open office environment, again, had more physical activity than those in cubicles, and in turn more physical activity than those in private offices. And this was indirectly related to the heart rate variability, the stress response that those participants had outside the office. So it's this idea of sort of taking your office home with you. So taking the environment that you experience home with you. You have these diurnal patterns, you have these patterns of your bodily systems, and if you can affect one, it's going to have to take time to recover at the end of the day. Just like if you have really bad sleep last night, you might be affecting it, might be feeling that right now. So this was just published a couple weeks ago. In occupational environmental medicine, and it got an incredible amount of media attention, and this is great because what we really wanted to have happen out of this study was not say, hey, we know exactly that this is causing this. We don't know that, but we know that it's probably a very complex problem, and a lot of people are really interested in this. So I'm sure everyone in here has heard studies about the bad aspects of open environments, and maybe this is one thing that we can learn is actually positive about that. So we're not interested in a one-size-fits-all solution. We're interested in advancing the conversation and understanding some of the nuances to have a more responsible design. I haven't talked about the environmental conditions yet, but one interesting thing that we've found is around relative humidity. So relative humidity measured by the sensors on the walls. There are a lot of problems with measuring humidity right here, as you can imagine, so we're talking about data from the walls right now. ASHRAE used to have a sort of standard between 30 and 60% relative humidity, and the low side has gone away in terms of any kind of regulation policy. But there really hasn't been any work done that ties human health outcomes to those ranges of humidity. They're all really sort of extreme circumstances or things that are tough to translate to human health. So that's one, really surprising, but also really interesting that we can start to do that work. And what we found were that people responded in terms of their stress response very similarly if they were in the very dry conditions, so less than 30% relative humidity, or very high humidity, so over 60%. So we found evidence that both of those categories were led to higher stress at the office. Whereas if you're in that middle sort of comfort zone, you had lower stress at the office. And interestingly, this was significantly related, indirectly again, to objectively measured sleep quality outside the office, of course. A couple other just sort of snapshots of what we're looking at and what we can look at. CO2 has gathered a lot of interest over the last few years. A lot of work out of Harvard, Joe Allen's lab. That's what these lines are, these vertical lines, these horizontal lines right here. So this is just parts per million with CO2, and you see a weekly pattern sort of the CO2 in a couple different types of office spaces. And what their lab has shown with the CO2 studies is that you may see some cognitive improvement on complex tasks when you're looking at things in this band between, say, 950, where that first line is, and 550 there. So we really see that that's where we're spending most of our time in the office in those kinds of environment. We're certainly in a higher CO2 environment right now. So we have room to play if that really does have an effect on cognition. Another way to sort of burst that bubble that might be around you, we worked with a Center for Built Environment to understand how CO2 was measured right here. It's very difficult to measure it right here, but in that process, we learned something about the bubble that you form around yourself. So it really is hot air that you are spewing out when you're talking, as you can see in this diagram here. And if there is something to the work that's been done recently showing the cognitive effects of trying to lower that ppm, the concentration there, just having a small fan pointing towards you blows that bubble away. Also walking around does, so that's another good thing to do. We also see a big difference in sound profiles between different types of rooms. These are just a couple of examples. Again, a Monday, Tuesday, Wednesday, Thursday, Friday pattern over a random week. We see a conference room and an open office room. It's not very surprising, right? A conference room is going to have a lot of variability and noise. It's going to be busy. It's going to be empty. But what was interesting in looking at tying that to a person's heart rate variability was that we see a sort of inflection point where measuring sound right here, okay, so if you're putting those decibels in context, you're measuring it right here, a little different than far away. You see a positive correlation for a while, and then you see a negative correlation. So up to about 51 decibels, we see a positive relationship. So you're getting more relaxed. There may be some sort of social protection. Maybe you're having conversations that are useful. And then after that point, perhaps they're getting a little more, annoying or too loud. So just a couple last words on what we're doing right now. We're really interested in personality. So we're tying together how personality can interact with the office type of space on a bunch of different dependent variables. One thing that is also tied to that stream is how we ask people questions. So everyone is aware of post-occupancy evaluations and pre- and post-tests that are one-time surveys. These are sort of global things. But what happens if you ask the person in real time, how do they feel right now about something? You get a very different profile. So for instance, you ask someone, how able are you to focus and be on task at work in general? So at sort of an intake survey. People in private offices say they love it. People in private offices say they love everything about their office, right? It's very consistent. But if you ask them in real time, you see a very similar response between those three office types of bench, cubicle, and a private office. So this is a really interesting type of thing. It's a new way of thinking about what do we really want to know when we're asking people these survey questions. And they probably are both interesting levels of understanding, to be quite honest. I was talking about the relative humidity thing. Just one note on this slide that we are working with ASHRAE for follow-up study. So again, really a lot of this work with the Wellbuilt for Wellbeing study is finding some things that spark new research and spark new understanding, and that's what's happening with ASHRAE. So with that, I'd like to close and thank the massive team that makes all this work possible, including Ryan Schindler, who is here in the audience. So thank you.
Questions for Casey? No? All right. Thank you.
Fair enough. Thank you.
Yes? All right. Wait for the speaker.
I see rather often there data about the response in hormones, but I never had the information. How is it measured?
So in our study, we did not measure cortisol. That was in a previous study, but we measured heart rate variability. So that's measured through a device that you wear on your chest. And it, just like a fancy, if you were in a hospital and you had a fancy EKG hook up to, it's like a simple version of that. So it's a lot noisier, but you still get a lot of good information, and the sensors are getting better every year. And through that, we work with the physiological team to get various measures of heart rate variability, and each one of those different measures tells you something different about the parasympathetic or the sympathetic stress response. So you get into the weeds really quickly, and I'm not going to pretend to be an expert here, but the heart rate variability is what we're interested in, so how irregularly your heart is beating rather than really fast and consistently. So you can think of if you're on a treadmill, your body's in a stress state, you're running. Your heart is going faster, but more importantly, it's very regular, right? You can remember being very regular. If you're very stressed, you're meeting a deadline, your heart's also probably going to be very regular. There's not a lot of variability there. The variability there is an indication that your parasympathetic system, your relaxation state is kicking in. So that's what we were interested in, seeing averages that were a little bit higher in terms of that response.
Thank you.
Thank you.
All right, again.